Okay, this is continuation of 3-4. We're going to do a little bit more of finding zeros of polynomial functions. I've already done some on the part 1 video, but on the part 1 video, the ones that we did were easy to find because they were all in your calculator, or they were all whole numbers, or relatively easy to find. So we're going to do one that's not quite as easy to find. So they've given me this polynomial function, x to the 4th minus 6x squared minus 8x plus 24. And they've asked me to find the zeros. Now, sometimes they'll give you one, a starting point, a place to jump off, and sometimes they don't. In this case, they didn't give me anything. So I am going to plug this in my calculator and look for a zero. If you can find one zero, then that's a good place to start off. So that's what I'm going to do. I'm going to plug this into my calculator, just like it is. So I'm going to go x to the 4th minus 6x squared. Hopefully there will be at least one that I can see. So I'm going to go to my table to look for one, and there's one right there, 2. Now I'm going to look and see if I can see the others. If I scroll my table, yeah, I don't see anything. Might possibly be a decimal or something like that. I could look at the function itself. Let me zoom standard and get back to my regular window. Alright, so I can't see anything but that one. Now it does look like that is a double root because it touches and turns, if you remember doing that. So it looks like that's going to be 2 of my 4, because according to the fundamental theorem of algebra, I should have 4 total zeros. But that means I need to find the other 2. So what I'm going to do is I'm going to use the one that I found, and I'm going to synthetically divide. So I have to set up my coefficients. Notice I'm missing the 3rd degree. So I'm going to do 1, a 0 to hold the 3rd degree, -6, -8, and 24. So 4, 3, 2, 1 constant. So I have all of my places. And I'm going to put 2 in the box because that's the 0 that I found on my calculator. Now we're synthetically dividing, so I bring the 1 down. 2 times 1 is 2. 0 plus 2 is 2. So multiplying here, write the number down, and then you add straight down. Multiply, add straight down, and multiply. And it should be a 0. If it doesn't come out to 0 at this point, you have done something wrong in your division, because I know it's a 0 because of my calculator. Now, in this case, it has given me a new polynomial to the 3rd degree, because this was to the 4th degree and it's 1 degree down. So my new polynomial would be x cubed plus 2x squared minus 2x minus 12. That would be my new polynomial. However, that does not help me because I can't factor this. But I did see that that 2 was a double root, which means it counts twice, which means I can synthetically divide with 2 again. So I'm going to set up my new coefficients, 1, 2, -2, and -12. And I'm going to synthetically divide again. And again, it's a 0, as it should be, because I knew it was a 0, it was a double root. So this now gets me to a quadratic, x squared plus 4x plus 6. So this is my new polynomial. Now, I'm trying to find my other 2 zeros. So far, I know that x equals 2. That's what I have found out. And technically, that's a double root, so x equals 2 again. Now, I could factor this if it would factor. But the factors of 6 are 1 and 6, and 2 and 3, and none of those add up to 4. Which means I have to use my favorite quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. I'm plugging in these values. That's a, that's b, and that's c. Now you're not going to plug this in your calculator because you want an exact answer. So I'm going to plug in it's -b, so it's going to be -4 plus or minus the square root of b squared, so 16, minus 4 times 1 times 6, all over 2 times 1. And I'm just going to simplify this. -4 plus or minus the square root of 16 minus 24 over 2. Keep simplifying. It looks like I've got an issue here. If I continue to simplify this, negative 4 plus or minus the square root of, looks like negative 8, so I have an imaginary number under here. Not only that, but 8 can be broken down with a factoring tree, if you remember. Square root of 8, 4 and 2, 2 and 2, a group of 2's, 2's go out, the group goes out, the loner stays home. So this is actually negative 4 plus or minus, this group went out, 2i, square root 2 over 2. Now one more issue and I'll be finished. I have a 4, a 2, and a 2 all on the outside, and they are all divisible by 2. So I'm going to go ahead and do that to simplify this. So I get negative 2 plus or minus I square root 2. Now this is actually 2 separate answers, and on the computer you have to type them in separately. So when it asked for a solution set, remember 2 was the first one I used to synthetically divide. That's a double root, so that counts as 2 of my 4. And here are my other 2. You have to type them out individually. Negative 2 plus I square root 2 and negative 2 minus I square root 2. So that's my solution set. And it was to the 4th degree, but because of the double root, there are only 3 answers. So that's what you do if it's not quite as straightforward. If you get down to that polynomial and it doesn't factor, you'll have to use the quadratic formula. Let's do another one just to have the practice of doing that. Let's see. X to the 4th minus 6x cubed plus 22x squared minus 30x plus 13 equals 0. So I'm going to first plug it in my calculator and look for the first 0. So I'm typing in x to the 4th minus 6x cubed plus 22x. Oop. Oh my goodness. If I'll ever get it in here. Minus 30x plus 13. Going to my table to look for a 0. Uh-oh. Doesn't look like I have one. So I'm going to go look at the picture. All right, it does pass through. I'm zoomed strange, and my calculator has some burnt out bulbs. I'm going to zoom 6. And it does look like it passes right here. Let me zoom in. See if I can see it a little better. All right, so I can see that it does pass through the x-axis. My calculator is burned out right here, but it's passing through right here. So I'm going to do a 2nd and a 0 to see if I can find it. Let's see where my cursor is. Oh, there it was. So I'm going to go to the left of it and then to the right of it. Wow, and so I do have a 0, but this time my 0 is, make sure, oh, I see what I did wrong. It's a plus 22. Oh my goodness. All right, now maybe I should get a 0. Yeah, there's one. 1 is a 0. Whew. Okay, so I'm going to plug 1 in and synthetically divide with 1, negative 6, 22, negative 30, and 13. And synthetically divide. And I get a 0, but this is again to the 3rd degree. When I look at my graph, I want to check and see if it touches and turns. And it does. It touches and turns there at 1, which means I get to use the 1 again. If it didn't touch and turn, I would have to start using those possible zeros that we came up with the other day and guessing and checking until I found something that worked. But there we go, that works. And now I'm x squared minus 4x plus 13. This does not factor, so you have to plug into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, this is your a, your b, and your c value. So negative 4 is 4, plus or minus the square root of, remember, negative 4 squared is still positive, so it's going to be 16 again. Minus 4 times 1 times 13 over 2 times 1, which is 2. So now I'm just going to simplify this. It looks like I'm going to end up with another imaginary number. Let's see, I've got 4 plus or minus the square root of 16 minus 52. Square root of 30. This one simplifies a little nicer though. It's negative 36.
Josh Collier to the office. We need Josh Collier to the office.
The square root of negative 36 is 6i because it's a perfect square. So now this simplifies as 2 plus or minus 3i. So there's my remaining two answers. When I make my solution set, don't forget the one you synthetically divided with. 1, and then 2 plus 3i, and 2 minus 3i. So that's my solution set. So this is how you are going to be finding zeros of polynomial functions. Both the last video showed you if you can just find them in your calculator or if it factors, and this is if you have to use a quadratic formula.